architectures for 2021 and beyond.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. And make sure to check out www.azuredevops.show for past episodes and show notes. And the goal of this podcast, again, is to empower you and your teams with the information that you need to move fast and deliver consistent quality using the .NET ecosystem and run your software systems with confidence in Azure. For those of you running .NET and Azure-related user groups, I've done a lot of online video presentations lately, and if you run one of these user groups, I'd love to give a presentation for you in your group, so just let me know. Also, our sponsor and my employer, ClearMeasure, is a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And so if we can help, please get in touch. And if you are a .NET developer and would like a path to become an architect, we are hiring. Just apply on the website, clearmeasure.com. Several positions are still open at the time of this recording. Also, I've just launched another podcast, but a video podcast this time. It's called Architect Tips. And most of the episodes are very short and aimed at showing you something useful for designing software built on the Microsoft platform. So go check it out. architecttips.clear-measure.com, or just do a Google search or any of the podcast directories. Today, I'm going to be sharing a short list of really interesting architectures to pay attention to in 2021 and beyond. The software development world is changing at a faster and faster rate every year. And as we look back, there are architectures, infrastructure, patterns that have turned out to be nothing more than just fads and a complete distraction when you look at it in hindsight. And I don't like that. The lost productivity, the dead ends, the broken promises. And so I wanted to share a survey of modern architectures that, in my opinion, have staying power in 2021 and beyond. So let's get to it. Let's go through the different levels of architectural patterns, and we're going to go through them one at a time with some examples in each that I think are a must know for 2021. There are so many architectural patterns that have been around for a long time, and the Gang of Four Design Patterns book has a lot of patterns where some of them, you look back and think, okay, they're kind of pervasive, but I don't really talk about that. There's 23 design patterns, and in common language, I see maybe 5 or 7 talked about these days in common form. But I'm going to talk about just more significant patterns at each of these layers, and this is 100% opinionated. In my opinion, these are the architectures that you should be paying attention to. You should know when you should apply them, and you should research. Now, in this webinar, in the short time we have, there's no way that I'm going to give you a full course on what these architectures are. But if you are not familiar with any of the ones I bring up, write it down and go research it. The information's out there. I'm not inventing any patterns here, but go research it. And so I'm going to name and talk about why I think that these architectures are the ones that you should pay attention to here coming up in 2021. So we'll start out at the infrastructure level, which is, okay, we have to have some infrastructure for our systems to run in, and then go down to the system level, and then the application level, and then a layer of an application, and the code level. Because there's patterns that apply at each of the different levels. And so if you just say, oh, we should use the we should use such and such architecture, the next question to communicate well is where. What context should I be talking about? So we're going to go through these different levels, because as you're designing an overall system, you need to make decisions at every one of these levels. And down at the code level, a lot of those things you just say, okay, you know what? It doesn't matter. However we implement it, it's fine. But you'll pick out maybe just a few patterns at the code level that you want to be pervasive. But the 4 layers above, much more strategic in nature. So let's start with the architecture level. Okay. For the infrastructure level, there is one that everybody should be paying attention to in 2021. And I know it's a buzzword, but let's just get past the buzzword, and that's serverless architecture. And I don't really like jargon. I don't like the buzzword. It's not, oh, you need to be serverless. A lot of people talk about going to the cloud. Why? Let's talk about the nugget of significance that is really powerful when you think about cloud. You think about not having to manage your own operating system. There are plenty of systems that get lifted and shifted to the cloud, and then they put VMs in Azure or VMs in AWS, but you don't actually get. You do get one advantage about being able just to scale up more VMs if you have, elastic processes like that. But the pervasive architectural advantage, huge productivity gains, and huge quality and stability gains across all three of those umbrella attributes: speed, quality, stability of your system are impacted by going serverless. Now, there are some applications and parts of an application that benefit and need to have an entire operating system. But there are a massive number of applications that makes no difference at all. So for the majority, you don't need the full operating system. You don't need access to the full operating system just to be able to process whatever you're processing. And so the nugget here is running the processes of your system on infrastructure that is less than a full operating system. You're going to have lowered maintenance. And then the restrictions that you have are restrictions you can live with. I can't install new pieces of software onto the operating system or make operating system level changes. That's fine. Now, if you're to go pure serverless or platform as a service resources in Azure, there's more restrictions, such as you can't install custom fonts. Well, if you have to print some barcodes to a screen, well, maybe you need a custom font. And so there's a middle ground with containers. If you can push all the way to serverless, which I would say for a lot of teams, over half of the applications that are deployed don't really need any of that stuff and can go full serverless. But if you need a little bit more control, you can back off of that and go with a container, where in a container, you can make some operating system changes and have a little bit more control. Containers are quickly being baked into the serverless offerings at all of the cloud providers. And so we're quickly going to see PaaS offerings, platform as a service offerings, that just accept a container where we just kind of throw it at the cloud and say, hey, run whatever's in this container, where it kind of merged and one and the same, where a container becomes the deployable package. Now, the tooling is not there now. It's a dream, it's a vision right now. And the people who are doing that now are investing quite a bit in R&D to do that. The tooling from Azure and Visual Studio right now makes serverless on PaaS offerings completely streamlined. But the container side is getting there very quickly. And Kubernetes is starting to get baked in. But the container stuff is just going to kind of be baked into the infrastructure, because most developers don't need to know how containers work. They just need to know, hey, run my stuff. All right, but that is the most significant pattern for the infrastructure level for 2021. All right, let's go down to the system level. And I'm going to have to hide myself just so you guys can see this. Let's go down to the system level. There's three that I want to highlight. One is domain-driven design. Now, domain-driven design is really old, but specifically bounded context. Okay, bounded context is the mindset around how to take a system and split it into multiple applications. Because most people now have heard, ooh, monolith bad, microservices good. Well, that's the simplistic way. We've seen and heard some horror stories about somebody goes the microservices route and then just realizes, oh, shoot, this was a big mistake. And then they come back somewhere in the middle. Microsoft's Azure DevOps Services team, that system is broken up significantly. And they kind of broke it up. And they have a whole article about how they broke it up to 100 and something different services and then realized, oh, wait, that's way too granular. And then they kind of pulled it back to 30 or 38, somewhere in there. Any new paradigm, people take it to the extreme and overdo it, and then the pendulum kind of comes back and we say, okay, what's the happy medium? Because it's a continuum. So the bounded context way of thinking has been defined for a long time. And if you have not read Eric Evans' book, Domain-Driven Design, I highly encourage you to read it and then go straight to the last third of the book and read the last third of the book first and then come back. Because now, when you're taking a system and breaking it up, they can be microservices or they can just be a system broken up into applications. And so the difference between an application and a microservice is how it's stitched back together. But either way, you need different bounded contexts. And a way to think of a bounded context is a part of a system where the terms, the nouns, the verbs, the definitions, the rules, the behavior are completely consistent. And that can be used to split those systems into different pieces, whether services or applications. And if you look at a particular application and you see that there's two different user personas, and if one type of user logs in and they have some logic, and a different type of user logs in and they need to see it as different, and you have some permissions and some business rules that say, if it's this type of user, do it this way, and if it's this type of user, do it this other way, that may be a seam where you have two different bounded contexts that are trying to be extracted. And you can simplify that system by letting the user types that have some significant differences operate in an application that is different. Okay, now microservices, that's breaking up the system into multiple applications the same way. We call them services, and there's some conventions that people are trying to push, but the architectural key here is with microservices is that the whole system is stitched back together and presented to the user as a single unified system. So if you look at Azure DevOps Services, you go to one URL, you click around, there's navigation, you do a bunch of stuff, and you just are in one place. But behind the scenes, there's 30-something different independent services that can all independently be deployed and changed. The same thing with Netflix. They've shared a whole lot about how they operate. You go to Netflix on a web browser or even on your smart TV, and you are in the Netflix, quote, Netflix app. But behind the scenes, there are just tons of little independent services that are all feeding things to a unified UI. So microservices is when you break apart the system into lots of different code bases that are independently built, tested, deployed, but the whole is presented back to the user as a single unified system, which is different from just tried and true decomposition of a system into multiple applications, where you have a system as a construct of branding, but maybe people know that they are going to the such and such application of the system, or the such and such application of the system, and maybe they have different URLs or different programs that are installed locally, and they are aware of different applications, because we're not trying to hide the fact that we decomposed it. We just say, hey, we decomposed it. So that is a key architectural difference in system decomposition from microservices. And you need to think, does this thing need to be presented as a unified, single unified application to the user, or could it be, multiple applications, and we don't need to hide that from the user? But either way, you're decomposing them. Now, the next is distributed architectures, which does impact how the different applications or microservices interact with each other. And distributed architectures have been talked about for a long time, but they kind of keep coming back down to two different major architectures. One is event-driven and one is web services. Now, I hate the term web services because it implies HTTP. And web services don't have to be HTTP. Really, the two different architectures are event-driven, which inherently is asynchronous. Now, some of you out there are saying, no, you can do event-driven synchronous. Okay, while technically you could, 80% of the time it doesn't make sense to do that. Maybe you have one scenario where you can, but just on broad brushes here, you have event-driven, which is typically asynchronous, and then you have the point-to-point connection, which web services are very commonly used these days, that is synchronous in nature, where one service or one application calls a web service of another and waits for the response. And maybe sometimes we fake asynchronous by polling, every few seconds or so. But web services are popular these days, but it's not inherent to the architecture. It could be any kind of remote call protocol, but it is synchronous. And it is that, and the direction of dependency with these architectures is different as well. The direction of dependency is, for event-driven, is that the actor, application A, is the actor, an event happens, and it doesn't know about application B. Application B has called over to application A and subscribed to a particular event, got on their list, so that when the event happens in application A, we know, hey, we're going to send it over. With web services, application A knows application B and specifically calls over to application B. Okay. Now, across the system, you can mix and match these two. So these particular two, event-driven web services, these can be mixed and matched. It is not all or nothing. And only small systems are one where you would only have one. The larger systems, yes, you're going to have some areas where you want to synchronously call and you want to get a response right then and there and have a blocking event on the call stack. and others where, you know what, I just want to kind of fire and forget, be asynchronous. And when I say event-driven, I'm also lumping in things where you would asynchronously send a command or send the query where it's really a business transaction. It's like, hey, the language changes. The language changes. If I'm going to take a loan application on a website, and that's going to be application A, and then on the back end, we have some loan processor, then application A is collecting a loan application and basically needs to know, hey, is this loan approved? Well, for web services, you could just call a web service and ask and wait. But the event-driven way would be say, okay, I have collect a new loan application, and the event would be loan application submitted, and it goes to the queue. And the backend service says, oh, I want to know about those, and receives all the loan application submitted events, churns through, and decides, okay, accepted, rejected. I know I'm simplifying the domain. Accepted or rejected, and then the event is loan application decision made. And then that event flows back, and the web UI for where someone goes to apply for the loan receives that event back. Okay, so even though at a system wide you may think in commands or queries, you change the language to be what has happened, what did happen. Well, this person did submit an application, and then over in the service on the back end, there was a decision that was made. Okay, so that's how you kind of change the language into events. Make them asynchronous. Okay, so let's jump down to the application level. And there are 4 of them that I think are must know for 2021. Again, there's too many to cover. MVC and MVVM, I'm lumping the 2 together because whether it's web applications or desktop applications, there has been and continues to be a huge renaissance in native style or rich stateful UI applications. Regardless if you're using a JavaScript SPA framework, or you're using WinForms or WPF with .NET 5, or you're going to be using the new Blazor framework, or you're developing an application directly for Android or iOS, more and more applications demand stateful user interfaces as opposed to page-based interfaces that are just websites, dynamic websites that we're going from page to page. So when you are saving state in your user interface, this class of pattern is critical. In my opinion, it's very useful in the page-based side as well. But MVC and MVVM, both of them call for the splitting of the user interface into 3 parts. And the difference is the order that they appear on the call stack. So in MVC, you have your model, which is data. You have the view, which is the visible layout, and then you have the controller, which is the behavior or the interaction with the rest of the application. In MVVM, you have the model, which is the data. Then you have the view, which is the visible layout. Then you have the view model, which is the class, instead of controller, it's called view model, which is the behavior or the interaction with the application. Now, the key difference is the order that they appear on the call stack. With model view controller, the controller gets the call stack first. And the controller has some branching decision. A lot of times, sometimes the model will be passed in, and the controller needs to just take it and use it. Or sometimes the controller needs to take one model and go get a different model, and then the controller decides the view. In MVVM, the view actually gets to the top of the call stack first, and then delegates to its view model class, which has the controlling logic. So that is a very key difference between these patterns. Which one gets to the top of the call stack first? I tend to prefer model view controller because I would prefer a class that does not have dependencies on visual UI controls to get on the top of the call stack first, because I think it's a more useful branching because you can determine what view to go to. Because with MVVM, because the view, which is the class with all the coupling, with all the UI controls, because it gets to the top of the call stack first, it is so hard to keep behavioral logic, controlling logic from creeping up into that class because it's happening first. So it has to route things. It has to decide what view model to route things to. However, use one of those 2 patterns. Do not just have it all jump together. You need to make sure that you have some separation. Those are proven, and with the renaissance of rich stateful application user interfaces, those are going to be must-haves in 2021.
Many thanks to our podcast sponsor, Clear Measure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Next one at the application level is onion architecture. I've coupled that with layered architecture because that is the intentional thinking of how to structure the Visual Studio solution that the developers are going to be using. And the structure of the Visual Studio solution manages the dependencies in that application or microservice, which whether it's a known invisible application or whether it's a microservice, either way, each is developed as a Visual Studio solution. Okay. And every Visual Studio solution needs to have a project which is clean. And in onion architecture, it's called the core project, where it doesn't have references to hardly any NuGet packages except for just the .NET and framework base class library. It doesn't have access to Blazor or Entity Framework or Auth0 or PayPal or any kind of other thing. It is truly portable code, and you might as well have that project be a flavor of .NET Standard, so that you can use it anywhere, because then you have a whole bunch of logic in the middle that truly is portable. It can run on the web, it can run server side, it can run in WinForms, WPF, it can run in iOS, it can run in Android, because you've managed your dependencies. So pay attention to onion architecture and manage your dependencies and keep them from getting into your business logic and into your core model classes, which should be in a protected library. And the difference between onion architecture and layered architecture is the order of dependencies. Layered architecture typically goes user interface down to the core project or business layer, sometimes called, and then down to data access. So it would have your core layer directly referencing a project that has dependencies on interface type libraries. Whereas the onion architecture, you depict it as concentric circles. And so that depicts where the core project is in the center and everything else references it. So every other project is an interface, whether it's an interface with data, whether it's an interface with an API with another system, whether it's an interface with the human, which is the user interface. And that truly keeps the core portable. In layered architecture, the core is not portable. The core is tied to the data access libraries that you've chosen. So that kind of has a hindrance when trying to run it in environments that don't have access to that directly, like smartphones and running the application on a Fire TV or running the application and all that logic directly in Blazor WebAssembly, things like that. All right. So pay attention to onion architecture. Next one is CQRS, and I've coupled that versus structured programming. I've included a good write-up that I like on that, the URL on the screen. Feel free to take a screenshot. And CQRS stands for Command Query Response Segregation. And so we use objects to encapsulate the user's intent, which is oftentimes input, and we use objects for output, and we keep those in object form throughout the application. Structured programming, though, is still the most common across the different layers. And with structured programming, a UI class would call a method on a business class, which would call a method on a data class, which would call the database. And those are method calls, all right? CQRS changes everything to fully implement object-oriented programming. So even today in 2020, and I work with so many development teams, I see a ton of people working with great object-oriented environments like .NET 5 and C#, but still doing just structured programming, just have methods calling methods calling methods. And one thing that's really popular is MVC controller, and the controller calls a service class or interface, which calls a repository class or interface. But when you look at what's happening, you have a controller method coming in, and then a controller method calls a specific service method, and the service method calls a specific repository method. So flip that around and think, okay, how would I make it object-oriented? Well, that's what CQRS gives you. You start with wrapping up the intent of the user as an object. So in the controller, you would create a submit loan application command. And that would be an object that represents what the user is wanting to do. And then the controller passes that into the application. And we'll talk about patterns, hub and spoke patterns for receiving that. And then there's an array of handlers that can handle a particular command. And those are one public method classes. The handler objects only exist to process a command or a query. And then the response also is a specific type, a specific object. And so we want to make everything an object. You want to object all the things. All right, last one is Onion DevOps architecture, which I'm giving it, I've coined that term from writing my latest book, .NET DevOps for Azure, which, by the way, if I haven't mentioned before, anybody who would like one, I want everybody to have that in their hands. If you would like a complete ebook copy of .NET DevOps for Azure, just send me an email or even chat and Rain, who's helping me with this webinar. You might even be able to get it before the end of the webinar. But one of the two ways, I want to get that in your hands. I'll give you the full ebook for free. Of course, you can find it anywhere books are sold for a physical copy. But there's the patterns for DevOps are still emerging, and I didn't see one that was complete. You've got patterns like continuous integration. You got patterns like continuous delivery, but they're so confusing. People are mistaking continuous integration for an automatically triggered compile process and say, oh, we have CI in place, but they don't. CI has three distinct steps that include 2 builds and 1 deployment. And most people I hear are saying we have CI in place and they have an automatically triggered running of msbuild.exe or .net.exe when they make a change to the git source control, and that's all it does. Or that's all it does, and maybe it runs some unit tests. And that's not continuous integration. And that's not even a complete integration build. So these DevOps architectures are still emerging, and they have a profound effect on the productivity of the team and the quality of the team. And if you think about a production environment, we think about production environments for the software system that we're designing. But the production environment for the development team is the DevOps environment itself. Think about it. If that goes down, can the team work? The development team is users of the layman's term overall development environment. The modern jargony word is DevOps environment, which is kind of the new word for a modernized development environment. The development environment term of old used to just mean, hey, how do you have your workstation set up locally, and do you have a test environment? And that's overall the development environment. A DevOps environment is a very specific thing, and it includes 2 types of builds, 3 types of automated test suites, and 3 distinct types of environments. And you do that, you put that in place, and you're going to have guaranteed quality. When I talk about 3 environment types, you can have as many environments as you want, but there are 3 distinct types of environments in a DevOps pipeline. That's a whole nother talk, and I've done a training course on that, but actually other webinars on that. As a quick aside for that, we do have a DevOps architecture poster. If any of you would like a high resolution copy of this poster PDF, it's meant to be printed 2 feet by 3 foot. This is actually only the top third of the poster. You just can't get all of it on the slide. And I know that you can't read the text; it's too small. But it depicts every step and what needs to be there for a complete DevOps environment. If any of you would like the high resolution PDF of the full poster, then by all means, just ask in the chat or send me an email, and I'll make sure that you get it, because it's a good resource. And even we've seen this pattern applied to just countless numbers of applications and microservices, and the dust is kind of settled. If you put all of these things in place for any of your code bases, then your team is going to move faster and the quality is going to increase. So it's a tried and true pattern. Okay, let's come down to the layer level. Now, a particular layer of a particular application or microservices, and I'm not really a fan of something being called a microservice and only having 2 or 3 classes. I know it's possible from a technical perspective with the cloud services and especially Azure Functions to just essentially declare 1 class or 1 function and have it running as an independent process up there in the cloud. I know that's possible, and in some super high scale scenarios where you just need to crank and process and do one thing and just need to do a whole bunch of it, that can make a lot of sense. But for the most part, our applications and microservices are going to be very comfortably sized Visual Studio solutions, ones that are not too big where you're forgetting where things are, but at the same time, you're going to have a few layers because you still need to manage the dependencies, and you still need to have your core project and keep the interface libraries away from that core project. So you are going to have layers. And even within the layers that are represented by Visual Studio projects, you're going to have other layers within a project that are represented by namespaces. And so there's a couple of patterns in the Gang of Four book that I wanted to highlight that I think are a must-have in 2021 for modern applications. One of them is the adapter pattern. And that's used in interface layers to create a domain level interface that your application controls and then wrap it and keep off to the side the details of a dependency. And so if we need to charge something through PayPal for a transaction, maybe our application core just needs to make a charge, but we need to call PayPal in a very specific way. So the adapter creates an abstraction so that the whole application can speak in application domain language. Hey, I need to charge this customer. Now, the fact that we are using PayPal is behind the adapter, perhaps. All right, the next one is, I put two together, mediator and chain of responsibility. Now, you couple this with CQRS, and the command objects are routed to single handlers, and that's the mediator pattern. But these two tend to go together because a lot of times within a particular application, you'll have commands or queries that need a direct one-for-one response, and then you'll have events in the application that are one-to-many. But you still need to route them to where they need to go without coupling. So we use mediator to achieve decoupling between layers so that the UI doesn't have to know about the types of the classes, the C# types of the classes that are handling those requests. And then chain of responsibility handles the one-to-many case where we have an event, and that event needs to be routed to any of the parts of the application that care about knowing that that event happened. Okay, now both mediator and chain of responsibility and many more are part of an overall family of pattern called hub and spoke. You hear about a hub and spoke architecture. Every framework on the planet uses some implementation of hub and spoke. If you just look at the MVC ASP.NET framework in the pipeline, it starts out coming into an HTTP module. Well, that's the abstraction. That's the hub. There can be tons of modules. Those are the spokes. We route it to the MVC module. And now we're in the MVC land. And so we route it to the routing engine within MVC. Well, guess what? That's the hub. Every route is a spoke. We find a match. We send it down the spoke for the particular route in MVC. And now we're in an area in the MVC framework that has to decide which controller class to instantiate. Well, that's the controller factory, if I'm remembering it correctly. That's the hub. And so we know it's the index controller. And so now that controller is a spoke. We route it to the spoke. And so it's this chain, it's these nesting of hubs and spokes to finally get to our code. Well, a lot of developers, that's where it stops. And then our code, it changes to just structured programming of methods calling methods, and maybe some classes sprinkled in, but we don't keep the hub and spoke going. And so that's something, if you haven't done this yet, really study hub and spoke architecture and look at the code of the Microsoft frameworks that you're using, because it's everywhere. And so an instantiation in every application of at least one hub and spoke abstraction would be an application bus, where your UI can just create a command or a query, send it to the application bus, and let the application bus be the hub. And one possible spoke could be the mediator implementation. And there's a great library called literally mediator, doesn't have the O in it. Use that for request processing, but also another spoke could be used for automatic auditing of the whole application. And also another spoke could be for remoting to another application that's over the network, whether async or not async. So every application needs at least one hub and spoke architectural element, and an application bus is one of those that is universally applicable. And for those of you using the mediator library, you're kind of getting that application bus pattern for free. But I would encourage you to, just like with any other dependency, wrap that library. Don't use those APIs directly, just like any other dependency you're getting from the outside. Wrap it and use your language. That way you have one level of indirection so that you can add on these other things quickly, like the auditing and remoting. Something's always going to come up. Okay, the last one is observer. And this is hugely valuable. And this is another Gang of Four pattern. So it's really old, but it's a key one to pay attention to in 2021. It's hugely valuable in stateful UIs. With composed screens where you have maybe left navigation, top bar, maybe you have a few panes, but you've got a screen. And again, it doesn't matter if it's a JavaScript SPA framework that has a screen in a browser, or Blazor WebAssembly, or WinForms, or WPF, or even an iPhone app. You've got a screen that is comprised of multiple areas. And you quickly get to a point where you want to have those different areas refactored into different user interface classes. So you've got a compose screen. Let's say you hover or click on one area of the screen, and that behavior, that interaction by the user is of interest to something in the other side of the screen. I mean, it could be as simply as if you have navigation, a main area, and then a properties pane, and you click, maybe the properties need to update. You do not want to have your developers messing with sending direct events and having one area of the screen knowing about what happens to be loaded in another area, subscribing to a .NET multicast event with a direct code reference, and then getting the signal that way. No, you want to wrap up that event as an object, and you want to send the object down what I call a UI bus. Again, this is another hub and spoke, but all of the spokes are observers. Okay, and so if something is clicked or something is hovered, something hovers, and that pane just says, "Hey, I have an item hover event. Hey, UI bus, this just happened." I don't care what people do with it, but it's just fired. Hey, this happened, this happened, this happened. And the properties pane, all it has to do is subscribe to the UI bus, and with C# interfaces, just declare, "Hey, what objects, what events, what event types do I want to listen for with just an interface?" And that's that. And this keeps each component from having to know the type, the C# .NET type of the other components. So make sure that you understand the observer pattern and how it can be used interacting with hub and spoke architecture for stateful UIs. Okay. Now, for different design patterns, you are going to want to know how to describe these, how to show them in pictorial format. You're going to want to be able to create diagrams that show boundaries, that show directions of interaction, and also directions of dependency, and be able to widen out and zoom in. So you're going to need to be able to create diagrams. And so just as an example, talking about the C4 model for describing software architectures, you have some code on the left, and it just happens to be one implementation of a bus pattern, but we need to describe what this bus is. So we have a diagram on the right where in the middle you see synchronous application bus. Now it happens to wrap and use the mediator library as a helper because we don't need to implement the whole thing. We got great libraries to use. But you want to be able to create these diagrams to communicate the patterns that you intend to be implemented. And so PlantUML is a great way to do that. And I'll let you see the whole thing. This is PlantUML with the C4 extensions, and this is a component level diagram, which is level 3 in the C4 model. First level is system, then it is container, then component, and then code or class. But if you have any questions about this, then I'd be happy to answer those. We've had some other courseware where you can use Visual Studio Code for this. Put these text files in your Git source control with your application, and now you've got versionable diagrams on the spot. All right, we'll finish up with the code level. I know we're hitting, but generic code patterns, functional programming style, and object-oriented logging. Object-oriented logging is where the toString method describes the object so that you can just throw your object at a logging library and it's there. These are you probably know the most there, but if you haven't looked at how generic code patterns, how the gang of 4 patterns split up into creating objects, object structure, and object behavior, you probably want to ramp up on that. But object-oriented logging, what that kind of gives you for free, this is an application insight screenshot, is where you can basically throw events and commands with overridden toString methods, and all of your application performance monitoring tools just kind of work for free. Okay. I know we just covered a lot, and each of the architectures and patterns that I covered could be expanded on a lot, but I hope this was helpful. I'll probably be using a few of these for episodes of the new Architect Tips video podcast, but until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.